In this video, we are going to discuss how to solve quadratic inequality. Inequality consisting of quadratic polynomial or quadratic inequalities. They may be any one of the following four types: ax square plus bx plus c less than 0, or less than or equal to 0, or they may be of the type ax square plus bx plus c greater than 0 or greater than or equal to 0. Now, solving these inequalities means finding those values of x for which the inequality is satisfied. Simple method is solving the quadratic equation ax square plus bx plus c equals 0. That will give us critical points, and around these critical points lies the solution of these inequalities. Let us see how this is done. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Let us solve the inequality 3x square plus 5x minus 2 less than or equal to 0. Here the left hand side of this inequality is a quadratic polynomial. First we will write quadratic equation 3x square plus 5x minus 2 equals 0. This can be factorized as 3 into x plus 2 into x minus 1 upon 3 equals 0, equating x plus 2 to 0 and x minus 1 upon 3 to 0. We get two critical points, x equals minus 2 and x equals 1 upon 3. Now to find the solution, first we will draw a number line and plot critical points on it. Say minus 2 here, 1 upon 3 here. We will consider three subintervals. First, from minus infinity to minus 2, we will consider a point x equals minus 3 and substitute in equation 1. That will be minus 3 plus 2 into minus 3 minus 1 upon 3. This is a product of two negative numbers which will be a positive number. But according to inequality star, this first interval does not satisfy the inequality. Now we will consider second interval minus 2 to minus 3, and we will consider one sample point x equals 0 within this interval and substitute in equation 1. We get 0 plus 2 into 0 minus 1 upon 3, which is product of a positive number and a negative number, giving us a negative number. So this second interval satisfies given inequality star. Finally, we will consider the third subinterval 1 upon 3 infinity, and we will consider a sample point x equals 1 within this interval and substitute in equation 1. That will give us 1 plus 2 into 1 minus 1 upon 3, which is a product of a positive number and a positive number, which will be positive. And we can see this interval does not satisfy inequality star. So the only interval that satisfies given inequality is closed interval minus 2 to 1 upon 3, and this is the solution of this inequality. Minus x square plus 3x minus 2 greater than or equal to 0. This we write as minus of x square minus 3x plus 2 greater than or equal to 0, x square minus 3x plus 2 less than or equal to 0. Factoring x minus 2 into x minus 1 less than or equal to 0. Critical points x equals 2, x equals 1 on a number line. We represent 1 here, 2 here. So in the first interval minus infinity to 1, we take x equals 0 and substitute in 1. 0 minus 2 into 0 minus 1 will be positive. That does not satisfy equation 1. So we put a cross here. In the second interval 1 to 2, we put x equals 1.5. So 1.5 minus 2 into 1.5 minus 1 will be negative, which satisfy equation 1. So we put a tick mark here. In the third interval 2 to infinity, we will put x equals 3. 3 minus 2 into 3 minus 1, a positive number, not satisfying equation 1. We put a cross over this interval. So the only solution in which this inequality is satisfied is closed interval 1 comma 2. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.